Good afternoon, everyone, and welcome to the research results presentation. My name is Mike Fitch with the Ohio LTAP Center here at ODOT, and we appreciate your participation. As we get started, please take a moment to locate the questions box in the GoToWebinar panel. During the presentation today, please use the questions box to send in any questions you might have. Looking at the handout section of the GoToWebinar panel, please note also that a PDF copy of today's presentation is available for reference. With that, we will go ahead and turn things over to Dr. Abbas. Hello.
Good afternoon, everyone, and thank you for joining the results presentation for the research project titled Optimizing the Performance of Item 404 Low Volume Traffic Mixes, or 404 LVT mixes. I would like to start my presentation by introducing myself. My name is Ala Abbas. I'm a professor in the Department of Civil Engineering at the University of Akron. I specialize in infrastructure, materials, and pavement engineering. I've been at the University of Akron since 2005. I've led several research projects on asphalt materials, including asphalt binders, asphalt emulsions, asphalt mixtures. Before joining the University of Akron, I worked for the Turner Fairbank Highway Research Center, which is the research arm of the Federal Highway Administration, as a highway research engineer. I would like to acknowledge my co-author and collaborator for this research project, Dr. Munir Nazal. I would like to also acknowledge the participation of several individuals from the oral TAC, including Mr. Steve Luby, Mark Isher, Jeremiah Upp, Perry Riccardi, Jacob Lotan, Jim Marzel, for their help throughout the research project. I would like to also thank Ms. Vicky Faut for her time and assistance throughout the project. In this presentation, I'll go over a background for the 404 LVT asphalt mixtures. I'll talk about the objectives of this research project. I will cover the research approach, which includes a survey, an online survey, to document the current state of the practice of using 404 LVT asphalt mixtures in the state, the experimental testing plan that we followed, the field performance evaluation that we did. I'll talk about the results from the laboratory testing plan and the results from the field performance evaluation. At the end, I'll go over a cost comparison between 404 LVT asphalt mixes and type 1 surface mixes. I'll go over the findings and conclusions and present the recommendations for implementation. So item 404 or 404 LVT mixes, these are basically asphalt mixes. It's a recipe mix that was basically developed by Flexible Pavements of Ohio based on an audit mix that is called item 404. This mix, basically, the last time it was used in the audit specification was in 1997, and it was removed from the 2002 construction and material specification book. So this item 404 mix included an asphalt mixture that had a finer gradation. AC20 asphalt binder was used for this mix, and traditionally 6% asphalt binder content was used for limestone aggregates, and 5.8% asphalt binder content was used for gravel aggregates. It was really an item that included asphalt mixes not only for low traffic, but low, medium, and high traffic. The component for the low traffic was picked up, modified, and reintroduced by Flexible Pavements of Ohio and the asphalt industry in 2008 as 404 LVT, which is basically a recipe mix that had finer gradation than the audit item 404 mix. It contained 30% trap with PG64-22, 40% trap with a polymer modified asphalt binder, The asphalt binder content was 6.4 when using limestone aggregates and 6.2 when using gravel aggregates. So you can see that it allowed for using a high percentage of RAP, and also basically it allowed for using a polymer modified asphalt binder, which is a stiffer asphalt binder. This mix was used by some agencies with basically varying results, and that led to basically the modification of the 404 LVT specification in 2015 by Flexible Pavement of Ohio, where the RAP content was reduced to 10% when using PG64 -22 and 20% when using PG58 -28. So you can see that the stiffness of the asphalt binder was reduced, and the amount of RAP that can be used in the asphalt mixture was also reduced as well. In terms of binder content, the binder content was increased to 6.8% when using limestone aggregates and 6.6% when using gravel aggregate. And this is basically a comparison between the aggregate gradation for 404 LVT asphalt mixes in the 2015 specification and the gradation for item 404 as it showed up in the 1997 construction and material specification book. When the gradation basically goes to the left, this means that you're using a strictly finer mix than when basically it is at the right, where you can basically have a coarser mix. This line in here is basically the maximum density line. So if you use a gradation that is exactly on top of the maximum density line, you're going to get basically as little air void as possible in your mix. And the more you deviate from that maximum density line, the higher amount of air void you're going to have in your asphalt mixture, which will allow you to put more asphalt binder in the mix. So the objectives of this study was really to optimize the 2015 404 LVT specification for use by local public agencies in Ohio on low volume road. And as part of this study, we examined the effect of different mix design factors, such as asphalt binder type, asphalt binder content, aggregate type, the source for the aggregate, the RAP content. So this way we can again validate some of the field observations that basically were made by some of the previous efforts to basically modify the mix design for this asphalt mixture. The main objective was to improve the performance of 404 LVT mixes, especially with regard to long-term cracking. And as part of the objectives, again, one of the objectives was to recommend changes to the current 404 LVT specification to make the mix possibly even more cost effective. So what do we mean by that? One of the things that we looked at is the RAP content. Again, do we need to use 10% or 20% or 20% RAP in this mixture, or we can actually go up a little bit for this mix to basically reduce the cost of the asphalt mixture. Since we are using a high percentage of asphalt binder in the mix, again, is there a way to offset part of that cost without compromising the performance of the asphalt mixture? So for the 404 LVT survey, a draft survey was prepared and sent to the TAC for review. The actual survey was sent out on September 29th, 2021. And responses were requested by October 15, 2021. And we extended the deadline by about 2 weeks to allow more people to participate. This is basically, these are the slides from the survey. So we asked for contact information, type of agency. This was really the main question that we had in the survey. Do you currently use 404 LVT, or you don't? If you don't, did you use it in the past, or you have never used it? If you use the 404 LVT, we asked for additional questions about how satisfied are you and how extensively do you use it, and when did you start using it? If you stopped using it, what are you currently using and why you stopped using it? And if you never used it, what do you currently use it, and are you interested in basically looking at the specification at the end of the project when we have them. And then permission to contact. Do we have the permission to contact the person who responded to the survey? So these slides, the following slides, basically present a summary of the responses. So from those who responded to the survey, several counties indicated that they currently use 404 LVT. We had Fayette County, Muskingum County, Miami County, Madison County, and Darke County. Some counties and cities said that they used it in the past, but they no longer use it. And other counties basically said that they have never used it. And from those, again, responders, some of them said, yes, we are interested in getting more information at the end, or they are happy with the mix that they basically have. One of the main reasons why this project basically was initiated by ODAT and the oral research project is because some local public agencies were not happy with type 1 surface asphalt mixtures when used on their roads, and they were looking for basically a better quality mixes that meets their needs that are different than basically the needs of ODAT. So this is basically why this research project got started. So when asked about the reason why you stopped using it or why you don't use it anymore, one of the most common reasons was that it's more expensive than a type 1 surface, and that's actually a valid concern. The other basically comment was that it's not available from local asphalt plants. And in the case of one county, they basically had complaints about cracking less than 4 months after installation. Now, I didn't really get more information about which particular specification was used. Was that basically an older specification or the newer specification? Again, the specification significantly changed in 2015. So I didn't really have information about whether it was the earlier specification or the newer specification. But again, it was a complaint that was raised by one of the counties. So to evaluate the effect of different mix design factors on the performance of the 404 LVT specification, we looked at the 2015 specification and we examined the factors that are basically covered. So you can see basically we have the binder grade. It basically allows for 58 minus 28 or 64 minus 22. The asphalt binder content, you can see basically the total asphalt binder content listed in here, and you can see the virgin asphalt binder content basically listed in here. The wrap percentage, again, 20% versus 10% for when using PG 58 minus 28 and 64 minus 22. The type of coarse aggregates, it's not restrictive in terms of what type of coarse aggregate you can use. There is some language that talks about basically having a minimum of 50% of the virgin 5 aggregate to be natural sand. Some contractors were using 100% of the virgin fine aggregate to be natural sand. So we wanted to look at the effect of the fine aggregate. We wanted to look at aggregate sources coming from different basically locations within the state. We wanted to look at the aggregate gradation. Again, these control limits, are they valid or not valid, or what is their effect? Traffic volume, this particular mix basically in here called for a maximum average daily traffic of 2,500 vehicles per day. So we wanted to look, is that reasonable? Is that too high? Is that too low? We don't have any requirement for truck traffic, and truck traffic lots of times basically control the performance of the asphalt mixture. So do we need to introduce additional requirements for truck traffic? The specification also included some language regarding quality control, construction, and acceptance. So we basically reviewed these requirements as well. To evaluate the effect of the asphalt binder, we used 4 asphalt mixtures with limestone, gravel, aggregates, and we varied the asphalt binder type between 58 minus 28 and 64 minus 22. We kept the binder content the same as what we had in the specification, and then we took it one step higher, and we looked at the effect of the asphalt binder content. So instead of basically just looking at the asphalt binder content at the specification, we increased it by 0.3% and we decreased it by 0.3%. So this way we can see how sensitive is this mixture to the asphalt binder content? And also we can answer the question, is the binder content in this mix higher than it should or lower than it should? Again, keep in mind that the binder content was increased in 2015. So are we there yet, or do we need to add more asphalt binder in the mix? Or possibly do we need to go down because it's too much? So again, we looked at the effect of the asphalt binder content. We looked at the effect of wrap. We used 20% wrap, and we basically increased it by 5% for PG58 minus 28. And for PG64 minus 22, we used 10%, and then we went up to 20%. So this way we can compare basically the effect of the binder content really and the effect of the wrap. Now, typically, when using a softer asphalt binder like PG58 minus 28, you can incorporate a higher percentage of wrap in your asphalt mixture, and that's a common practice basically by ODOT, where basically a softer asphalt binder like PG58 minus 28 is specified when you have a higher percentage of wrap, or when the wrap binder stiffness is high to the point that you need to use a softer asphalt binder. In terms of effect of coarse aggregate, we looked at limestone gravel blend. In terms of fine aggregate, we looked at natural sand only and natural sand with limestone sand. In terms of aggregates, we obtained aggregates from different counties. These are not the sources of these aggregates. These are just the aggregates where we obtain, these are the locations where we obtain the aggregates from. So we basically obtained aggregates from Fayette County, Darke County, Miami County, Madison County, Athens, Cuyahoga County, and Richland County. So we basically looked at, again, different asphalt mixes prepared using the 2015 flexible pavement specification, and we basically compared the performance of these mixes, and we evaluated the effect of these specifications on the mix performance. For the evaluation of the performance of the asphalt mixtures, we used 4 laboratory tests. The first test is called the indirect tension tensile asphalt cracking test. This is a test that was recently selected by ODOT for consideration for use to evaluate the fatigue cracking resistance of asphalt mixture. So it's really a cracking test. It tells us about the ability of the asphalt mixture to resist cracking. We used the AASHTO T283, also called the modified Lutman test, that is used by ODOT to evaluate the moisture sensitivity of the asphalt mixtures. We used the Hamburg wheel tracking device to evaluate the rutting resistance of the asphalt mixtures, and we used the asphalt concrete cracking device to evaluate the low temperature performance of the asphalt mixtures. So this slide demonstrates the procedure that is used in analyzing the laboratory test results from the IDLCT test. So in this test is simple to a traditional indirect tension test, where you have a diametral specimen, you're loading it along its diameter vertically at a loading rate of about 2 inches per minute or 50 millimeters per minute. You're taking the load versus deformation results, and instead of just looking at the strength, the indirect tensile strength of the asphalt mixture, you actually take the whole load versus deformation results, and you analyze them to calculate the CT index, which is basically an index that is used to indicate the performance of the asphalt mixture with regard to cracking. This index parameter is based on the area under the load versus displacement curve, which is captured using the fracture energy. It also looks at the slope of the post-failure load versus deformation curve. So brittle materials typically have a high slope, sharp drop in force, whereas ductile material, which are more favorable for fatigue cracking, they basically have a smaller slope. It looks at L75, which is the displacement corresponding to the location where we calculate the post-peak slope, and we have T, which is the thickness, and D is the diameter of the specimen. We used a 6-inch diameter by 62 millimeter specimen height to perform the IDLCT testing. For AASHTO T283, we used the same test device where we basically measured the indirect tensile strength of conditioned and unconditioned specimens. So unconditioned specimens are specimens that are not subjected to conditioning, and conditioned specimens are specimens that have been subjected to conditioning, which involves basically freezing and thawing of the asphalt mixture. So upon conditioning, you would expect the strength to drop. Looking at the percentage of drop or the percentage of the original strength of the asphalt mixture, we calculate the tensile strength ratio, and we use that parameter to determine if the asphalt mixture is susceptible to moisture-induced damage or not. Usually, mixtures that are more susceptible to moisture-induced damage are mixtures that are coarser in aggregate size, where you have more void inside the asphalt mixture that would allow the moisture to basically penetrate through the asphalt mixture. When you're dealing with a finer gradation aggregate mixture, when you're dealing with a richer, with a mix that is richer in asphalt binder, traditionally you're not too concerned about the susceptibility of the asphalt mixture to moisture-induced damage, unless if you're dealing with, for example, aggregates that have cleanliness issues, or you have some compatibility with regard to adhesion between the asphalt binder and the aggregate. But other than that, usually you should be good with regard to basically the moisture-induced damage. But we did the testing to basically look at the results. This is a picture of our Hamburg wheel tracking device. In this device, we're basically applying a steel wheel on the asphalt mixture, and we look at the rotting accumulation. This test is conducted underwater, and the temperature of the water is maintained at 50 degrees centigrade. The air void of the asphalt mixture is 7%, and we apply 20,000 passes up to a maximum rod depth of 25 millimeter. Now, this basically number of passes means that you're going to have 10,000 cycles times 2 passes. That basically is how you get the 20,000 passes. These are again these are the triggers for the device to stop the test, and the test will continue until you basically either reach these values, or also if you have basically irregular deformation between the two specimens, also the test may also be stopped. Now, these are sample results that we get from the Hamburg wheel tracking device. You can see that in terms of deformation, the asphalt mixture goes through 3 phases. The first one is called the primary, then the secondary, then the tertiary stages. And when you're dealing with softer asphalt binders, you're going to basically reach that tertiary stage faster than if you're dealing with a stiffer asphalt binder, where you may not even see it, and the test will continue without you actually reaching that point. Now, several rotting parameters have been proposed in the literature. So some people basically looked at the minimum number of passes corresponding to a target rod depth. Some people looked at the rod depth that correspond to a certain number of passes. Other people basically looked at the stripping inflection point, or even the slopes of the deformation curve during the secondary or the tertiary stages. In the literature, Yin et al. Basically summarized the criteria that are used by different states for different types of asphalt binders. Traditionally, when using basically softer asphalt binders, the temperature may basically be reduced to allow basically the test to continue for a larger number of cycles. Since we're using basically 64 minus 22 and 58 minus 28 in here, we decided to stick with the same testing temperature. And we used 50, which again, you can see that it has been used by some of the other states. And we used basically a maximum rod depth of 12.5 millimeter at 10,000 passes to compare the performance of the asphalt mixtures together. And this basically in here shows the minimum stripping inflection point of 10,000. These mixes are designed to be used at locations where we have lower traffic. So ideally speaking, rutting should not really be a concern, provided that it is used at the right location where you don't really have too much traffic. But again, this is something that we need to look at, because again, rutting happens at the early stage of the life of the asphalt mixture, and you definitely want to prevent rutting from happening in the field. The asphalt concrete cracking device, which was developed by Dr. Sansu Kim of Ohio University, was used to evaluate the low temperature cracking resistance of the asphalt mixture. This test basically looks at the deformation of the asphalt mixture when the temperature is dropped, and there are some criteria that are used to determine basically the cracking temperature of the asphalt mixture. Typically, softer asphalt binders like 58-28 will give you better low temperature performance than 64-22, and that's actually given from the name of the PG grade of the asphalt binder. When you hear 58-28, so the -28 for the PG 58-28 is lower than the -22 for PG 64-22, so you would expect to get better low temperature resistance when using 58-28 asphalt binders. Now, asphalt mixture performance with regard to low temperature cracking is highly affected by the PG grade of the asphalt binder, because low temperature cracking happens due to basically the shrinkage of the asphalt mixture when the temperature goes down. So it's really a tensile stress that is controlling that failure mechanism. And since it's a tensile stress, the glue that is holding the aggregates together is going to play a significant role in determining the performance of that asphalt mixture. Laboratory test results. So this slide shows basically the effect of the asphalt binder content on the indirect tensile strength of the asphalt mixtures using the IDLCT test. You can see in here basically that when we use 58-28 asphalt binder, your strength is going to be slightly lower than when we basically use a PG 64-22. We did not really get a big difference in strength between limestone and gravel. You can see that limestone mixes basically have slightly higher strength values than gravel mixes, but in general, again, we're still in the bulk part close to each other, basically with regard to strength. You cannot really compare the effect of the RAP, because these were prepared at 20%, like the specification calls for, where these two were prepared at 10%, like the specification calls for when you use 64-22 versus 58-28. But in terms of more like the effect of the asphalt binder, you can see that the binder content is basically, when we increase the binder content, lots of times we got a slight reduction in the strength, but it's not really as clear and as evident basically regarding the effect of the indirect tensile strength. Increasing the asphalt binder content usually results in a larger area under the load versus deformation curve. So you usually see an increase in the fracture energy for the asphalt mixture, and we are seeing that basically in the test results. When you increase the amount of asphalt binder, you also get a more ductile behavior, and that's more clear really in the test results in here, that when we increase the asphalt binder content in the asphalt mixture, we are getting a more basically ductile behavior than when we have a lower asphalt binder content. This is basically the displacement that corresponds to the location where we calculate the post-peak slope. And again, it should increase because your material is basically becoming more ductile. If you want to think of the strength and the displacement as anything, I would use the Marshall flow and stability. So the stability is more like you're capturing the strength of the asphalt mixture, and the flow, you're capturing the deformation. So you can see again, when you put more binder, you get more deformation or more flow in your asphalt mixture. This is basically the cracking parameter, CT index, that was calculated basically at the different asphalt binder content. And you can basically see in here that, again, when you increase the amount of asphalt binder content in the asphalt mixture, the mixture become more resistant to cracking, but then we start getting more concerned about basically rutting. And you can see in here that when we added 0.3%, there was this big jump in CT index, which indicates that, again, we are at a point where, again, the mix is starting to become very rich in asphalt binder content. This slide shows the effect of the asphalt content on the tensile strength ratio. You can basically see that when we used 58 minus 28, we got better tensile strength ratio values than when we used 64 minus 22. Why is that? When you use 58 minus 28, sometimes because it's a softer asphalt binder, you might actually get a little bit better absorption into the aggregate, so that will give you a little bit better adhesion between the asphalt binder and the aggregate. And when you measure the strength, that can basically show up in your strength measurements. We are not really seeing a big difference between the limestone and the gravel mixes. You can see that again for both asphalt binders. And you can see that when we use the 58 minus 28, we always got more than 70%. But when we use the 64 minus 22, sometimes we got basically less than 70%. So again, 58 minus 28 gave us better performance with regard to moisture-induced damage than 64 minus 22. This slide shows the effect of the asphalt binder content on the stripping inflection point. You can see that, again, the more binder we basically added, the stripping inflection point became less. That means that, again, the susceptibility to the rutting became more. But again, you can see in here that in the bulk range for some of these mixes, again, the binder basically content gave us more than 10,000 cycles, and that's basically what we were looking for. In terms of rutting, you can see again that a higher rut depth was obtained when the asphalt binder content was increased. The effect of the binder content was more with the 58 minus 28 than with the 64 minus 22. And again, that tells you again how sensitive is this mixture to the binder content. It's always good to look at the effect of the binder content on the performance by increasing or decreasing the asphalt binder content. And that's really the main idea behind the balanced mix design. Try to increase, decrease the asphalt binder content, look at the effect of rutting, look at the effect on cracking, and see where is that sweet spot for both rutting and fatigue cracking. So in here, basically, for these asphalt mixtures, for this particular mixes, which were really prepared using limestone, gravel aggregates, natural sand aggregates, wraps that were obtained from the Fayette County, we basically obtained asphalt mixtures that have reasonable performance with regard to rutting in the lab. So we wanted to check, is that consistent with what we are observing in the field? You can see that 64 minus 22 gave us better rutting resistance than 58 minus 28. Based on the results that I showed before, 58 minus 28 gave us better fatigue cracking resistance, moisture-induced damage resistance than the 64 minus 22. And in this slide, I'm showing the effect of the different PG grades on the low temperature performance of the asphalt mixture. In here, I'm really showing it for a much larger number of asphalt mixes. But if you look at these test results, you can notice that basically the low temperature cracking measured using the asphalt concrete cracking device was mainly affected by the type of the binder in the mix. It was less affected by some of the other factors. And again, that's what we expected. Binder plays a significant role with regard to basically low temperature performance. So in here, you can see that 58 minus 28 basically gave us better low temperature performance than 64 minus 22. So again, to summarize, 64 minus 22 gave us better resistance to rotting, but 58 minus 28 gave us better resistance to fatigue cracking, moisture-induced damage, and also low temperature cracking. For the sake of time, I'm not going to go over the results for all the other effects because, again, I have, in addition to basically binder grade and binder content, I basically have the effect of the aggregate, coarse aggregate type, fine aggregate type, wrap content, aggregate source, and so on and so forth. So for the sake of time, I'm going to continue with presenting the results for the field evaluation, and I will be commenting on the results that we obtained for the effect of the other factors toward the end of my presentation. So in the lab, we do a mixed design to really come up with a mix that we hope will give us the best performance in the field. But the ultimate really evaluation is really how the mix performs in the field. So we went back and we contacted some of the counties that indicated that they are using 404 LVT mixes or have used 404 LVT mixes. And we evaluated the performance of several pavement sections that were constructed using the 404 LVT specifications. Now, we targeted years coming from 2015 to 2017. One thing to keep in mind is that all the sections that were constructed in 2015, they were still using the old specification, not necessarily the newer specification. So the binder type is different, the wrap content could be different, and so on and so forth. But again, we wanted to see how these mixes perform. And we have, again, 2016, 2017. Now, for Fayette County and Miami County, we were able to get basically mixes from all years. For Darke County, we basically got, we were not able to find any mixes from 2015, but we found mixes from other years, and that helped us with the field evaluation. Now, why did we shoot for 2015 to 2017? And again, the evaluation is conducted basically in 2020, so 7 years later, because usually within 7 years, you are going to basically see a combination of performance results that you obtain for the asphalt mixture. If you go to a location that has been constructed more than 10 years ago, then there is a higher likelihood you're going to see a lot of cracks. And if you go to a new section, then you're basically going to find a shiny road. And that's basically not what we were looking for. We were basically wanted to see a combination of distresses at the different locations. We used the ODOT performance or pavement condition evaluation form for local asphalt roads. And this is basically how the form look like. So you evaluate ravening, bleeding, patching, surface disintegration, rotting, map cracking, base failure, settlements, transverse cracks, wheel track cracking, longitudinal cracking, edge cracking, pressure damage or upheaval, crack sealing deficiencies. In here, we were basically not trying to calculate a pavement condition rating for the locations. We were more interested in looking at what type of distresses do we have, what is the severity, what is the extent of these distresses. So we did not really care about calculating the pavement condition rating, so we did not even use the key to calculate the rating. We were just basically trying to look at what distress do we have, what is the severity, and what is the extent. So this slide shows a list of the pavement sections that were evaluated in Fayette County. Again, you can see that we have sections constructed in 2015, 16, 17, and you can see in here basically the traffic level at these locations. And you can see that some of these basically locations had higher traffic. So this way we can again look at the effect of the traffic on the performance, but lots of them basically had relatively low traffic. This slide shows a summary of the performance evaluation results for Fayette County. You can see that raveling was observed, but again, it was low severity raveling. We only had raveling at a couple of locations that were more obvious. Transverse cracking was the more common, basically, type of distress that we observed in Fayette County. We only had basically one location where we had basically a more moderate longitudinal cracking. And if you remember from the previous slide, this is really one of the locations where we had basically higher traffic at this site. These are basically selected pictures from different roads where the 404 LVT was used in Fayette County. Again, transverse cracking, which is a low temperature thermal cracking, was commonly observed in several of these sections. And again, very minor signs of raveling basically were observed in most sections. This is basically the list of sections that were evaluated in Darke County. You can see we basically have 2017. We did not have 2015 or 16, so we have 2017 and 18. Okay. And in here, you can see the traffic level. Traffic level in here is basically relatively lower. So you can see it's all less than 1,500 vehicles per day. And this basically slide shows a summary of the performance evaluation results. You can see that we only had, basically, we had little raveling in here. So that's one. Okay. And we basically had minor, very minor, actually, it's if you see in here, we have LO. So this is low severity and it's occasional. It's not even extensive, basically, for the low temperature cracking. And we only had one site where we had basically a moderate severity longitudinal cracking. And when I contacted Darke County to discuss the results, they told me that this site is located in a floodplain. So it makes sense that it has more basically longitudinal cracking than the other basically sites. And you can see in here that, again, this section was constructed in 2017. So again, it looks in a very basically good shape. You can see minor cracks basically at this section, but the sections were relatively in a very good shape. Now, one of the difference between Darke County and, for example, some of the mixes that were used elsewhere is that in Darke County, they mainly use limestone. And limestone in general is less associated with raveling than natural gravel. So again, it made sense that, again, we observed less basically raveling at these sections than some of the other sections in the other counties. These are basically the sections that were evaluated in Miami County. And again, you can see they are mostly 2,000 or less vehicles per day. And this is basically the performance evaluation results. Again, you can see that wherever we had basically higher traffic, we basically tended to see more distresses. Transverse cracking was, again, the main type of distress still that we were observing. Some raveling, some longitudinal cracking, but again, low temperature cracking was the more observed in Miami County. And for Miami County, they use more basically gravel than limestone. Sometimes they use a limestone gravel blend in their mixes. So again, we can observe some of the effects of the different aggregates on the results. In the next slide, I'm going to show a comparison between 404 LVT and type 1 surface mixes. Now, when you think of 404 LVT asphalt mixture, and you think of what type of aggregate is used in it, what type of asphalt binder is used in it, how much asphalt binder you're going to basically be putting in it. the first thing that you're going to basically be concerned about is that this mix has a lot of asphalt binder in it. So it will probably be more expensive than basically a type 1 surface asphalt mixture. And that's actually correct. If you get a quote for a 404 LVT asphalt mixture, it will tend to be more expensive than a type 1 surface asphalt mixture. And in here, I'm basically showing a comparison. I tried to basically prepare the cost comparison by keeping the wrap content the same. Just looking at basically, again, number 8 limestone natural sand. So I did not even put any limestone sand in the mixture. One of the recommendations that we have in this project is to use 58 minus 28. So I use that 58 minus 28 asphalt binder versus a traditional 64 minus 22 asphalt binder for a type 1 surface mix, and I did the comparison. You can see in here that we have less number 8 limestone than a type 1 surface. Number 8 limestone is more expensive than the natural sand, so that there's going to be a little bit of a cost saving in here. 58 minus 28 is usually a little bit more expensive than 64 minus 22, so you're going to pay a little bit more for the binder type. And again, the binder content is going to also make a big difference. So you can see in here basically the cost comparison that the mix in general is going to be maybe $5 to $10 more for the 404 LVT than the 4441 type 1 surface mix per ton. So again, should you be using 404 LVT? The main advantage of 404 LVT than type 1 surface is that you can actually use it at a lower thickness. So in here, I'm comparing basically the cost of an asphalt overlay placed at 1 inch thickness using 404 asphalt mixtures versus a 1.5 inch asphalt mix produced using type 1, item 441 type 1 surface and used for the overlay. And you can see in here that basically the cost of the item 441 type 1 surface becomes basically more expensive. Now you have to be a little bit careful when you view these results, because sometimes somebody may say, well, I don't necessarily always have to use 1.5 inch, I may use 1.25 inch. And if that's the case, then again, your price difference is going to be less if you have to use lower thickness. But with type 1 surface asphalt mixtures, we don't go to 1 inch. So the main advantages of the 404 LVT mixture is that you have the ability to go to the 1 inch. Now, do you always use 1 inch? Not always, because sometimes you may actually have to even increase it to maybe address some issues that are existing at the location where the mix will be used. But the main advantage of 404 LVT is that you can use it at 1 inch thickness as compared to item 441 type 1 surface. So findings and conclusions, as I've discussed already, with regard to the binder type, 64 minus 22 performed better for rutting, but we had better performance for the 58 minus 28 with regard to cracking, with regard to moisture-induced damage, and with regard to low temperature cracking. And from the field evaluation results, we've seen that low temperature cracking was actually important. So it will be favorable to use the 58 minus 28 instead of the 64 minus 22. Now, as we said, 58 minus 28 is more susceptible to rutting, so we have to be a little bit careful where we use the mix to make sure that we don't get rutting. In terms of asphalt binder content, again, one of the things that we wanted to evaluate was, is the binder content too high? Is it higher than it should? Is it lower than it should? And what we found is that basically the binder content that we have in the 2015 specification is close to that sweet spot for the asphalt mixtures. Again, we looked at the Fayette County mixes more closely, but we collected mixes from some of the other counties. Still, again, rutting would be a concern if you have too much traffic, and in particular, if you have too many trucks. When we asked the counties about what is the typical percentage of trucks that you have on your higher volume roads, and they basically came back and said that most of the time it can go up to 4 to 6%, but usually it doesn't go higher than that. But you have to really know how much trucks you have. If you're going to be using an estimate, then again, maybe you would want to use a higher percentage to be a little bit more conservative in estimating how much trucks you have. I would be less concerned if you have 25 vehicles per day if they are mostly passenger cars. But if you have a lot of trucks, you have to be a little bit careful with that. We did look at basically in the specification, it basically says add 0.2 percentage points of asphalt binder content if you're using high absorptive aggregates. And there is only one aggregate with more than 4% absorption in the state. So we lowered that percentage to 3.5 to exclude that aggregate from being used. So this way we don't really have to worry about this particular aggregate. Coarse aggregate type, in general, we got comparable results for both limestone and gravel mixes in the lab. But when we went to the field, we saw more raveling with gravel than with limestone mixes. Limestone as an angular aggregate provides better resistance to rotting than natural gravel. So again, whenever you have the ability to use limestone, it would be recommended to consider using limestone, but you can as well use gravel or a gravel limestone blend if you are concerned about basically rotting. Fine aggregate types, the current specification calls for using at least 50% natural sand. From our laboratory testing, we did actually notice an improvement in performance when we added limestone sand. So again, if you can add more limestone sand, it will be basically preferable to do that in your 404 LVT mix. In terms of aggregate gradation, we made very minor changes just because, again, when we were trying to basically do the recipe mix, we did have lots of times like we were hitting one of the blend limits that we felt that it can be relaxed. So we changed basically the percent passing sieve number 10, the lower limit from 10 to 8. On the other hand, we made the mix more strictly finer by increasing the basically the lower limits for number 8 and number 16. So this way we can force you to get a finer gradation mix rather than go coarser, because then if you go coarser, you need less binder content. And since this is a recipe mix, you're not going to be doing a full mix design, so it would be better to be more strict with your requirements. Traffic level, as I mentioned, again, the current specification calls for a maximum of 2,500 vehicles per day, but it does not really look at truck traffic. Truck traffic makes a more impact on rutting performance. So we said just adding basically a maximum of 100 trucks per day, and this is really a true maximum. You don't want to really exceed that number of trucks per day. Otherwise, rutting might start becoming an issue for your agency. Recommendations for implementation. This basically slide summarizes the changes that we proposed to the mixed design. And no changes were proposed for mixed production and placement, quality control, or acceptance. I reviewed those and with some people from ODAT and also with Flexible Pavements of Ohio, and they were reasonable to everybody, so we were good with them. I just want to remind everybody that this mix is intended for low volume roads. You cannot use it at a location where you have significant amount of cracking. You cannot use it at a location where you have significant rutting, and you have to use it at a location where you don't have too many heavy trucks. So you have to be very careful where you use this mix. With that, I'm going to open the floor for questions.
All right, thanks, Alla. As a reminder to our audience, the questions box is open, and we have received 2 questions so far. I have copied those into the chat. Alla, if you want to check there.
Okay, so question 1 from Robert. In regard to coast, 404 all need to be placed at 1 inch, where type 1 would be. I'm not sure I understand the first question.
Looks like the first would be placed at 1 inch, where type 1 would be 1.25 inch or thicker.
So I'm going to go to that slide. So in here, I took the more extreme case of 1 inch versus 1.5 inch. And as I mentioned, you can use 1.25 inch and you can adjust the cost accordingly for the mix. So it will be less expensive than, like currently we have a price difference of about $30,000 per mile of road, but it will be less if you use 1.25 inch. Not sure if I answered the question.
There was a question too from Mike.
Okay. So what is the projected extended life of the 58 minus 28 versus 64 minus 22? We did not really get to the point where we compare the projected extended life. To really be able to fully do that, you have to really have a long-term evaluation study. This could be a good recommendation for basically ODAT and the audit program to try to continue to monitor the performance of some of these roads and see basically if there is a difference in service life. Now, most of the counties that have used these mixes, they sort of more like used it about 10, 12 years ago. So we're starting to get there, but we're not really there yet where they have to even repave any of the roads yet. So again, I think this is a good recommendation to continue monitoring the performance of these roads to see when you will actually need to repave them. Okay, how does slow moving heavy farm equipment do on these mixes? You can use it on locations where you have heavy moving equipment, as long as, again, you have good ramps for entrance and exit. You don't want the heavy moving farm equipment to be trying to jump on the road from a farm on these mixes, because then it might cause a little bit of damage. But again, all the counties that we talked about, they are basically rural counties where heavy farm equipment are available and are being used. So you can use them actually on these roads. Okay. In your findings and conclusions, how do you determine the 2% reduction from person? How do you determine the 2% reduction for person passing sieve number 20, sieve number 50? So this is basically the conclusion. Similar to what is the common practice really for how you select the control points, okay, like from 10 to 8. When we prepared the mixes using the aggregates that were collected from different sources, based on the available aggregate gradations, lots of times we were hitting 9, okay? So control points for asphalt mixtures, lots of times they are basically determined based on performance, on how the mix will perform, but lots of other times they're also determined based on the available gradations that you have within the state. So with the available aggregate gradations, lots of times we're getting basically slightly below 9. So you can actually relax that if you can show from laboratory testing that you are getting good performance. And that's basically what we did, that we were getting the 9s and they were still performing okay, so we lowered that limit. Still, it's important for the mix to include finer portion of aggregates. You don't want it to be too small to the point where you have basically no finer aggregates in the mix. This is why the 8, basically. Same question, increasing number 8 and number 16 by 5%. number 8 and number, yeah. So these ones are, again, same answer. As long as you can get to meet these gradations with the available aggregates, you're okay with modifying the gradation limits as long as the mix performs basically well in the lab. Now, when you're dealing with a recipe mix, it's better to have a stricter control over the gradation, because you don't want the basically the person who's using the aggregates to start using gradations that are very different than what you used in the development of the mix design. So this is the reason why it's recommended to be a little bit more strict with the performance. And as long as the laboratory test results basically provide good performance, then you're okay with that. Are you starting to see more municipalities using a carbon neutral mix design? We did not really look at that as part of this research project. The transverse cracking shown in your photos appear to be reflective cracking commonly coming through the existing road base. You may want to core these locations and see if the crack continues all the way through the lower asphalt layers. That's actually a very good, basically, comment. And I think to add to your basically comment, this is where if any county or any agency want to use basically 404 LVT mixes, it has to really be part of a comprehensive plan, because you're going to be moving from one mix to another mix. My expectation is that you're moving from type 1 surface because you observed more cracking than you would like to a 404 LVT mix. So initially, when you do the implementation, you may need to go a little bit thicker with the 404 just to basically capture some of these cracks. Another thing is to basically the timing for when you place the 404 LVT overlay. If you wait too long, you're going to see more cracks in the pre-existing road, and these cracks can be basically reflecting. So it's really, I would say, a combination of both reflective as well as low temperature cracking. But timing can address that issue. Were you able to check shoving resistance at stop signs or curves? We did not really look at shoving resistance. I do want to basically comment that I've only noticed at one location from all the sites that I've visited a little bit of shoving. So again, you have to be a little bit careful again with basically where you use the mix, especially if you're using it for heavier traffic. But I did not see it really as a common problem. Actually, it was pointed to me when I was at that site that you have this issue. I missed it. I did not really even, it was not for me that clear to me. You have to sometimes go with magnifier and look for it to be able to actually see that. Do you know of any heavily shaded rows that you have placed, or that would you be interested to see resistance to raveling moisture? I will answer the second place first. Would you be interested to see resistance to raveling and moisture? I think you're asking me if I would like to see something that you can show me, and I will be more than happy to contact you to check regarding that. Now, do you know of any heavily shaded roads that have been paved with 404 LVT? Yes, actually, one of them was paved in Fayette County, close to the asphalt plant, and the mix performance, the county, talking to basically Mr. Steve Luby, he told me that, again, we took our chances and we expected that we may see some basically performance that is not consistent with the performance of the mix throughout the county. And it does, like driving at that location, it does look more rough than the other locations. So I guess to answer your question, yes, it was installed in front of an asphalt plant in one of the counties. And my recommendation is to try to avoid basically using it at a place where you expect these kind of heavy moving traffic. Comparing 404 LVT to a 441 type 1 surface seems to be an apples to oranges comparison, without analyzing 404 in comparison to SS860 thin-lay be of a more appropriate side-by-side comparison for each data type. I agree with you. I think if you compare the performance of 404 LVT to the performance of 441 type 1 surface in the lab, it will be a comparison between apples and oranges. This is why we did not really do that. We just looked at 404 separately. Okay. Now, with regard to the cost, you can still do a comparison based on the cost because people are actually using 441 type 1 surface. Not many are using the SS860 thin-lay on low volume roads, as far as I know. This is why we did the cost comparison between 404 LVT and 441 type 1 surface. Okay, I reached the end of the questions. Any more questions, Mike?
Did we get question 11 from Roger?
Okay, let me see. Can you read the question? I'm not seeing a question.
Yeah. Is the use for this mix for rural sections, or can it be used in small residential subdivisions that are curbed/uncurbed?
So it really depends on the conditions at the location where you want to use it. Okay, if you have a relatively flat surface where you can easily pave it and control the thickness to be the desired thickness, and you have a good foundation for this mix, then it can. However, if you are trying to use it in a residential area where that's not the case, it's a rural, the roads don't have the best foundation, so you're going to have extensive deformation in these pavements. You cannot really control the thickness to be 1 inch, so you may end up running into a lower thickness than 1 inch at some locations. Then you may want to be a little bit careful, basically, when using that mix. So it really depends on where you're using the mix. I think it's a very good mix if it's used at the right location.
All right. Thanks, Alla. Lots of great questions this afternoon, and we are actually past 2 p.m. at this point. So with that, we would like to thank Dr. Abbas for presenting today. We really appreciate it. And thanks, everybody, for your participation.
Thank you, everybody. Have a good rest of your day.